good morning, grade 11s. Thank you for doing your work so diligently, and I hope that you have done this table part of your homework yesterday, as that is the thing that takes a little bit of time. So going into grade 11 trig graphs for the first time, you are used to getting A equals sine x plus q and A equals cos x plus q and so forth. But now we are going to add a b. We are going to add a value in front of the x, and that b value, that value in front of the x, is going to change the period. So this investigation, what you should have noticed is when you drew these graphs, that a normal sine graph, we know, takes 360 degrees to complete a complete sine graph. What happened when I added a 2, it meant, and I did it on the side here, that instead of having a complete graph from 0 to 360, I now had one complete graph in 180 degrees and a second one for the next 180 degrees. So what happened here, the period of sine x was 360 degrees. What happened when I added the 2 is that it only required 180 degrees to complete one graph. Okay, now when you drew the sine x over 2, you would have noticed that it took 360 degrees to complete only half of a sine graph, and another 360 degrees to complete the second half. So when I divide it by 2, it actually takes 720 degrees to complete one graph. Okay, so looking at the table they gave me, so nothing else changed. The domain stayed the same, the range stayed the same, the amplitude stayed the same. But what happened? The graph was either pushed together or it was pulled apart. Okay, so a normal sine graph takes 360. We saw that sine 2x, it completes two graphs, so it's only required 180 degrees, and then we spoke about dividing by 2 takes 720. So how did we get this? There's formulas to use. So when I work with sine and cos, remember a normal sine and cos takes 360 degrees to complete one graph. So if there is a b value in front of the x, I will take 360 divided by b. Very important that the tan graph is a special one because it only takes 180 degrees to complete a normal tan graph. If there's a b value, I will divide 180 by b. Right, so when I look at the example, y is equal to cos 3x, what do I notice from that equation? My a value, my amplitude is still 1. The b value is 3, which means it's going to affect the period, which means that there's going to be more graphs within 360 degrees. So when I use my formula 360 divided by 3, I notice that it only requires 120 degrees to complete one graph. That means if I look at only half of the Cartesian plane from 0 to 360, I'm now not going to have one cos graph. I'm going to have one happening in 120 degrees, another one happening in 120 degrees, and another one happening in 120 degrees, which makes 3 cos graphs in 360 degrees. Just something I noted there, my q value is 0, so thank the Pope, we're not shifting up or down at the same time in this question. Now, just to make your plotting a little bit easier, even though they gave me the 180 and the 360, I am just going to add, that is my 90, and they have labeled or scaled my Cartesian plane using 30 degrees. Now, I'm doing this because it makes it a little bit easier when I do the plotting. Okay, now I need to warn you, because I'm going to have to plot more points, I am going to have to break my graph up in two halves. I'm not going to be able to do a full minus 360 to 360 again. If you do that, you're only going to land up with some points, which is misleading, because then you're only going to draw one cost graph on the negative side and one cost graph on the positive side. So here's a note. When I do have a period change, I need to do my plotting in two steps. Do the negative side, do the positive side. Why am I going to do that? Because when I am in table mode, I am going to, okay, so I'm going to start at minus 360. I'm going to end at 0. Important part is you need to reduce your step. If you leave it in 45, it's only going to give you those values. You need to go down to at least 30 degrees. Okay, so I'm going to do 2 of those. So in table mode, I'm going to put in 3 cos 3x. Okay, I'm going to start at minus 360. I'm going to end at 0. I'm going to make my step 30. By doing that, I'm allowing me to get enough points. If you put in minus 360 and end 360 and step 30, your calculator is going to throw out an error saying insufficient space. It doesn't have enough space. So let's see. I've got minus 360 and 1. I've got minus 330 and 0. I've got minus 300 at negative 1. I've got minus 270 at 0. And I've got minus 40 again at 1. So from 240 to 360, that's 120 degrees. That is my first bit of my cost graph. So now I go on. Minus 210, it goes back to 0. Minus 180, it's negative 1. Minus 150 is 0 again, which means minus 120 is going to be at 1. So there is another 120 degrees with another graph. Okay, I continue at minus 90. I've got a 0. Minus 60 will be at minus 1. Minus 30 will be at 0. And then 0 and 1. So within 360 degrees, as my cos was telling me, in 360 degrees, I need 3 cos graphs. 1, 2, 3. So now if I do my positive side, I'm going to have cos 3x, and I'm going to start at 0, end at 360, and my step is in 30. Okay, so at 0, I've got 1. At 30, I've got 0. 60, I've got negative 1. 90, 0. 120 is a 1. That's my first graph within 120. That means 150 will be 0. 180 will be negative 1. 210 is 0. And 240 is 1. 270 is 0. 300 is going to be negative 1. 330 is 0. And 360 is 1. So there I see I've got my 3 cos graphs in 360 degrees. So in 720, I had 1, 2, 3, 4, 5, 6 of them. Okay, so when we get to tan, it gets a little bit tricky. Okay, with the period change, you will have to do it in 2. Okay, that I've already said. But what do I know about tan? So here I see my A value is 1, but it doesn't mean much with a tan because I don't have an amplitude. My B value is not x over 2, it is a half. And my period for a tan graph is not 360, it's 180 divided by a half, which means it becomes 180 times by 2, so it will take 360 degrees to complete one tan graph. And what did they do here? They've moved it up 1 point. So I know already that I'm not going to start at 0, I'm now going to have to start at 1. Okay, very important with the tan graph. As the tan graph has asymptotes, I need to let my calculator help me because my asymptotes are not fixed at 90 and 270. That's only for a standard tan graph. If the period changes, the asymptotes will change as well. So I'm going to do it in 2 steps again. I'm first going to do the positive side, for instance. I'm going to have tan, and I'm going to have x over 2, oh goodness, 2. I'm going to close the bracket, and I'm going to add 1. And I'm going to start at 0, end at 360, and I'm going to change my step to 30 because there was a period change. So the first thing I notice at 0, I will have 1. So thank the Pope, I know that is where I wanted to start. At 30, so once again, that's 30, 60, 90. 120, 150. So at 30, I will have 1.2. So it's round about there. Okay, at 60, I'll have 1.5. That's more an accurate point. At 90, that's where my asymptote used to be. I will have a 2. 120, I'll have 2.7. That's around about there. At 150, I will have 4.7, that's round about there, and 180 error. That means at 180, I am going to add my asymptote. So what do I notice? I notice that my asymptote has shifted, and there is 1 bit of my graph. At 210, so 210, I'll have minus 2.7. At 240, that's there, I'll have minus 0.7. That is about there. And 270, I will have a 0. That makes sense because my graph has been moved up. At 300, I'm going to have 0.4, and at 330, I am going to have 0.7, and at 360, I will have a 1, which makes sense because my graph has moved up. Right, so in 360, I have 1 complete graph. I need to do the same now for the negative side. Right, and I'm going to start at minus 360 and I'm going to end at 0 and step. So according to my calculations, I am going to have an asymptote at minus 180. I'm going to start with a negative 1 at minus 360. I'm going to have 300, negative 300. I'm going to have a 1.5. I'm going to skip 270. I'm going to have 240 at 2.7. That is 3, so that's about there. And I can see my graph take shape to go up there. minus 180 is an error. That's fine. Minus 150 is minus 2.7. That's about there. Minus 120 is 0.7. That's 1, so it's round about there. I'm expecting at minus 90, which is there. I need to indicate that value, please. And minus 60, I have minus 0.4, and that's enough points for me to complete my graph. Okay. Now you're going to do exercise 2, number 1 and 2. For the first one, I want you to draw those three on the same Cartesian plane. Question 2, I want you to do the sines on the same graph, the cos graphs on the same graph, and the tan graph on its own. And then the next page is question 4, where I gave you a graph and you need to determine the A and the B value and the range. I want to go through number 3 with you as an example. So the two graphs I have is sine 2x. So what is that telling me? Within 360 degrees, I'm going to have two sine graphs. And here I've got 2 sine x. Now what does that mean? Within 360 degrees, I'm going to have one graph, but with an amplitude of 2. Okay. Look at this. I want you to make note of this. This is a change from grade 10 to grade 11. You will have restrictions. So you're only allowed to draw your graph between minus 180 and plus 180. Okay. So to save time at this stage, please pause the video so that you can draw those two graphs. I have done it ahead of time to save video time. It takes very long to upload these videos. So at this stage, please pause, draw these two graphs, use two different colors, because with the graph interpretation, that's going to help you. Right. So I assume that you have drawn your two graphs. Please compare it with mine. Please note there is nothing on the left of minus 180. There is nothing on the right of plus 180 because they restricted me to work in between those two values. Okay. Sine 2x I see has an amplitude of 1. And in 180 degrees, it completes one graph and another graph in 180 degrees. Okay. The pink one, 2 sine x, it takes 360 degrees to complete an entire graph, but it has an amplitude of 2. Okay. Don't get confused. Remember, when you start drawings, draw it from the 0 so that you go your positive and your positive, and then do the negative side. Okay. So B, they ask you, write down the amplitude of G. The amplitude of G has a value of 2. What is the period of F? Well, the period, the B value has changed. So 360 divided by 2 is 180 degrees. Now, this is the part that I wanted to get to. This is graph interpretation. You hate it. Okay. So what I'm going to do is I use colors. I'm just going to highlight all my F of G's. Oh, gosh, I had to make them pink. Make them yellow. Sorry for that. So I'm going to make all my F of X's yellow as per my graph that I drew, and I'm going to make my G of X pink. So it's easier for me to talk about yellow and pink than to get a tongue twister, F of X and G of X and all. Okay, So let's look at the first one. They say, where is yellow or f of x equal to 0? So now you go to your graph, which is in color, and you go and you find those points. So x at minus 180, minus 90, 0, 90, and 180. There's 1, 2, 3, 4, 5 0 points for f of x. Now they ask me, where is g of x greater than 0? So now I'm going to ask myself, where is my pink above my x-axis? Because above my x-axis is greater than 0. So pink is below, only starting at 0, but not including, because they say greater. So x will be from 0, excluding 0, and 180, it's on the axis, so it's also excluded. Right, now they ask me, where is my yellow equal to my pink? Right, so what do I notice here? From there to there, I have the same line. So x element of, that's negative 45, okay, negative 45, and that's plus 45, and they're both included. Okay, where is my yellow? Where is yellow above pink? Yellow above pink, and it's included. So it's from minus 180, above, until I hit minus 45, or where, and that's all. The rest I have pink above yellow. Right, now question 5 is the one I wanted to get to. Where will I have pink minus yellow giving me 2? Okay, so there they equal. Here I can see off my graph I have pink is a minus 1, yellow is a plus 1. So if I say pink minus yellow, I get negative 2 for that point. Is that what I wanted? No. If I look at this, yellow is 0 and pink is minus 2. So pink minus yellow is negative 2. Is that what I want? No, it's not. There they equal, there they equal, there they equal. Now I've got pink at 2, yellow at 0. So pink minus yellow, 2 minus 0 is 2. Is that what I wanted? Yes. Right, let's have a look here. I've got pink at 1 and yellow at minus 1. So I've got 1 minus 1, that's a 2. Is that what I wanted? Yes, it is. And then at 180, it's equal. So for which values will I have equal to 2 at x 90? And what will that be? 135. And x equal to 135. And the last one there, where will I have yellow times by pink greater than 0? So what does this mean? Greater than means positive when I multiply. So I either have a plus times a plus or a minus times a minus. So in graph terms, I have a pink or yellow graph above and a yellow graph above. That will give me a plus. Or I've got a yellow graph below and I've got a pink graph below that will give me a plus. So if we work in sections, above, below, or plus and a minus, no. Then I work into the next block. That's a plus and a minus, no. Then I go between minus 90 and minus 45. What do I notice? A negative and a negative, that's what I want. A negative and a negative, that's what I want. A plus and a plus, that's what I want. The next section is a plus and a plus, that's what I want. Here I've got a plus and a minus, that's not what I want. And a plus and a minus, that's not what I want. So I don't want those, and I don't want those. So between minus 90 and plus 90, I have both graphs below or both graphs above, which satisfies my answer. So X element, it is excluded because it's a greater than minus 90 and 90. Right, I hope that you understand this work and enjoy doing your homework. Question 1, 2, and 4.